We have talked about OWASP Top 10 before in the previous domain, but I figured it would be good to go over them all once more and a little more in depth. In these next slides, I'm going to be covering the current top 10 and some of the ones that were removed from the list, but you should still know. And they were removed from the list not because they're not vulnerabilities anymore, but because now they're maybe the 11th or the 12th, and this is a top 10 list. And the list is in order, meaning A1 is the most critical one. That's the one we have the most issues with, then 2 and 3 and so on. Let's start with A1, injection. Injection attack are attackers that inject codes into our user forms. This is most often SQL or LDAP, and the attackers are able to do this because we do not have strong enough input validation, data type limitations, or limitations on our input lengths. And in most cases, the fixes are pretty easy. We only allow the appropriate type of data to be entered into a field, meaning if someone has to enter the name, we only allow letters. If they have to enter a phone number, then only numbers, and wherever possible, we have drop-down menus. If someone has to enter their country, their state, their city, anything like this, we can use drop-down menus. And then finally, we limit how many characters people can use per cell. And if the attacker, or people just by mistake, enter something wrong into the cells, either the character won't show at all, or when they try to submit the form, they get told there's an illegal character in whatever field they entered, and they have to fix that before they can submit the form. We could possibly do this through a CGI, Common Gateway Interface. And that is a standard protocol for web servers that we use to execute programs running on that server, which allows us to generate web pages dynamically. And again, what that really just means is a dynamic web page is a web page that's generated based on what you enter. Back to the example of the hotel booking earlier, I enter where I want the hotel and the dates I want and maybe my price range, and then the CGI generates the web page I get presented using the backend database. But the CGI separates the user, which is untrusted, with the backend, which is trusted, that is the database. And since we have the input validation, we have the data typing, and we have the limit on how long the fields are, that hopefully should prevent anything malicious from making its way to the backend, at least for this type of vulnerability. A2 is broken authentication and session management, and there are a couple of ways that this can be a threat. This can happen when sessions either do not expire or they take too long to expire. With many protocols, after a certain amount of bits or bytes, a new session is established, or at a certain time interval, every 10 seconds, 20 seconds, whatever. We exchange new session keys, and then we keep working. All of this happens behind the scenes, so the user will never know as long as it keeps functioning. But if the session never expires, or it doesn't expire very frequently, it is much easier for the attacker to steal the session key and then send it to the server pretending to be the actual user. So to fix this, we obviously have sessions that do expire and they expire frequently. Another issue could be if the session IDs are predictable. And yes, this is a silly example. We would never use 001, but if they are in any way predictable, they are vulnerable. So every time we have a new session key, it should be random and it should not be possible for an attacker to guess it. And then obviously session IDs, tokens, passwords, if they're kept in plain text, that's a huge vulnerability. So they should never be kept in plain text, ever. And the two examples I have here over on the right, the top one, the legitimate user sends the traffic to the server, the attacker is eavesdropping on the traffic, gets the session ID and sends it to the server pretending to be the legitimate user. And then the bottom one, the attacker has infected the user's PC. Once the user sends the session ID to the server, it also sends it to the attacker, which then can do the same thing they could with the eavesdropping. They can pretend to be the real user. And both A1 and A2 seems like really simple fixes, and most of IT security to some extent is. But just because something is easy to fix doesn't mean we do it. It's still seen as an inconvenience or a nuisance. A3, cross-site scripting or XSS. With cross-site scripting, an attacker discovers a vulnerability on one of our servers. they're able to inject malicious code onto the server that will steal session cookies. So whenever a legitimate user accesses the server, or in this case the compromised website, the script activates and the cookies from the legitimate visit are sent to the attacker. In this case, we're not compromising anything on the user system. We're not stealing their traffic. We have found a vulnerability on the server and we're exploiting it on the server. And here again, we can use proper input validation and data typing. And then on top of that, we can add some extra security. And some of the things we can do to prevent cross-site scripting could be we could redirect invalid requests. We might have something that could detect simultaneous logins from 2 different IPs, and then when we do, invalidate the sessions. Even if we have a user that is by the system seen as the real user, if they want to change anything on their profile, they have to re-enter their password. I think most of us have tried this. Whenever you update any information on one of the websites you're registered on, first off, you have to enter your password. But once you make the change, an email is sent out to the original email address that you associated with the account, informing you that these changes were made. If you didn't make them, go check your stuff. And pretty much anything in the top 10 are there because we design our software for functionality and security is an afterthought. So again, security needs to be one of the functional requirements for the software, even if it costs a little more money and takes a little more time. A4, broken access control, often happens when we don't implement consistent access control across an entire application. We need to ensure, just like we did in Domain 5 when we talked about regular access control, that we have one centralized system that handles the access control and there are no exceptions. Any access to the database and to the website should go through our centralized access control mechanism. Ideally, we would want our access control scheme to be designed deliberately to ensure that the only way to access the database and the website is through that one security point, which obviously is secure enough. But that's not really how it happens in most cases. It is much more often something that kind of just happens as we go along. Oh, by the way, we should also allow users to access this part or this piece of the website, whereas before they might only have had access to other pieces of the website. The solution often is something that's not as secure as what we have in place already. Oh, we just add this web form and then they can log in. Problem fixed. And if we don't have that consistency and that centralized point for access control, we would have with regular access control. First off, it's not as secure as it should be. And secondly, it's near to impossible to manage because it was not designed in from the onset, it wasn't planned right, it was just something we added somewhere in the code to make things easier. You can think of it like our data center. We have a bunch of doors, a bunch of access points that people need to go through to get into our data center. But Bob doesn't really want to do that, so to make it easier for him to get into the data center, he makes a hole in the wall. And then he just puts some plastic over it. Same thing we're doing with a lot of our access to our databases and our web servers. We have the normal good security that we should have, and then we have some way of accessing the database or the server that is not secure at all, or at least not up to the same high standards as the regular login. And this becomes even more of a problem if our administrative interfaces are web accessible. If an attacker gets access to those, well, then they can do a lot of damage. We centralize the access control, we only allow the single entry point, and we spend the time to design and write the code properly and not just tag it on.